So waiting for the student to join. I'll wait for 5 to 10 minutes. I'll wait for 2 minutes more, then I'll start my lecture. Okay, then just do not waste the time and we are starting with the lecture. Okay. So if you would join later, then it would be fine. But try to be joined at at the time that is allotted to you. Okay. So yeah, hello student. My name is Arun Sharma, and I'm your physics teacher. So we are here with the lecture number 3 of geometrical optics. Okay. So let's just get started with it. Sorry, I just have mentioned lecture 3 over here, but it is lecture 3. Okay. So what is our aim for today? The aim is firstly, as we move uh, previously, we would first recall something, and then spherical mirrors, sign convention we are going to study, then the mirror formula, okay, and the focal length. Then we would focus something on the magnification of linear object. It is all about the spherical mirror. Then velocity of image that we are going to focus, although we have discussed it for the plane mirror also, but it is for the spherical one. Okay, so velocity of image here we have now the image formed by the spherical mirror. Okay. So this is it with that we are up to. And firstly we will recall the part that is essential for today's lecture also. Okay, so here we have with the relation between mirror velocity and the image velocity. Okay, we have done it in the previous lecture, case by case. So I'm just discussing the formula over here and the concept. Okay, so whoever has been not attended the lecture yesterday would get the benefit of it. Okay, so when object is moving and mirror is at rest, so we are going to do it here. Yeah. Hi Ninamat Naresh, how are you? Am I audible and visible to you? Just confirm it. Please write this in chat box if I'm visible and audible to you. Okay. Okay, thank you so much. Although you have responded. Hello, Janvi Ongole. How are you? So I'm supposing that if I'm visible to Ninamat Naresh, I'm sorry, then I'm visible to all of you. Okay. So I have just started the lecture. We are going to recall firstly and what we have done yesterday. Then we would move on to the next topic that we have. Okay. So I just want to that all of you are joining till now. So I just want to yeah, focus on this. So firstly, we will going to recall. It is lecture number 3. Don't confuse with this lecture number 2. It is lecture number 3. Okay. It is a typing error. Okay. So we will do the recall part. उसके बाद spherical mirror and sign convention we will see. Then mirror formula and focal length. Then the magnification of linear object. It is an important topic also. Then the velocity of image found by the spherical mirror. Uh, yeah, I have discussed it for plane mirror. Here it is for the spherical one. Now the हम पढ़ेंगे image found by spherical mirror. Okay, this is all we have to do. So firstly we would recall, yeah, the relationship. Hi Swati. The relationship between mirror velocity and hi Pooja and image velocity. So first case that we have over here is when object is moving and mirror is at rest. So here the case that we have, red color is not visible to you, I think, because I have seen the recording of this lecture. So yeah. So this is the plane mirror that we have. This is the object that we have moving towards it with velocity VO. Here is the image formed. Okay. So VI is the velocity of image. So hello Swati. Hello. How are you? Hope you're doing well. Let's just focus on the lecture. Okay. I glad you have answered. Okay. So this is the velocity of object, this is velocity of image. So we have the concept that velocity of object is always equals to the negative of velocity of image. Okay, so this is the formula that we have when mirror is at rest. Okay, we are measuring these velocities with respect to mirror. So you just kept this thing in mind that velocity of object with respect to mirror is always the negative of velocity of image with respect to mirror. Now, if mirror is at rest, then this case would follow. And if mirror is moving, then this case would be follow as the next one. So when mirror is moving also, so object is moving also like in certain direction we have mentioned, and mirror is also moving in certain direction. So this is the velocity of mirror. So we have two component. It is the what would we say? We will say the parallel component, sorry, the perpendicular one, because it is the perpendicular to the mirror, and this component along this we have the parallel component if we are moving parallel to the mirror. Similarly, this is VO, this is VO perpendicular, and this is VO parallel. So we would know that velocity of object parallel is always equals to velocity of image parallel. Okay, and what is the relation that we have learned yesterday for the perpendicular velocities? That velocity of mirror is the arithmetic mean of, like, velocity of object perpendicular plus velocity of image perpendicular. Sorry, just a second. Yeah, perpendicular. So divided by 2. This is all we have learned yesterday. Okay. I hope the screen is visible to you. If you find any trouble with this, the screen, voice, and my visibility, because it is also mentioned that I have to be look on. मुझे मैं दिखना चाहिए तुम लोगों को. ओके, सो अगर तीनों के साथ कोई भी प्रॉब्लम है, देन चैट बॉक्स में लिखो. ओके, मूविंग ऑन टू द नेक्स्ट. और यार थोड़ा टाइमली ज्वाइन किया करो, एट 3 पे ज्वाइन कर लिया करो. So the number of images found by two inclined plane mirror, we have discussed it. Okay. So here we have an object. This is the object we have. Okay. So इससे ये जो है इमेज बन रही है I1 और I2. यहाँ पे ये ऑब्जेक्ट M1 मिरर से अल्फा एंगल पर सिचुएटेड है. इट इज प्लेस्ड इन एंगल अल्फा फ्रॉम द मिरर M1, and from the mirror M2 it is placed in angle beta. And what is theta? Theta is nothing but alpha plus beta. Okay, so here we have this number n is equals to 360 by theta. If theta, like theta is equals to 90 we have. Okay, so what would we get? We get n is equals to 4. Okay, so n is an even number. So the position of object doesn't matter then. कहीं भी हो object, the number of images would form is n minus 1. और इस केस में कितने बनेंगे? 3 images भी है. Okay, anywhere मतलब कहीं भी हो सकता है, वो कहीं भी placed हो. Means alpha और beta then play no role. Okay, when n is even. But when n is odd, then alpha and beta came into the picture. So for symmetric position, alpha must be equal to beta. Means जो object है वो mirror के एंगल बाइसेक्टर पे होना चाहिए. Okay, जो एंगल को इक्वली बाइसेक्ट कर रहा है उस पोजीशन पे ऑब्जेक्ट मस्ट बी सिचुएटेड देयर. Okay, now for the asymmetric one, and this is not n minus 1, this is n. Okay, yesterday I have also mentioned it. Sorry to forgot to correct it. Okay, I'm so sorry for that. So this is n. So asymmetric means alpha is not equals to beta. Okay, एक तो numerical आ सकता है यहाँ से, maybe in neat. Okay, now the object and the image that we have learned. Firstly, the object is nothing but the, what is the object? Object is the point of intersection of incident rays. Okay, the rays which is coming from where it is coming, that point is the object, or we can say the source. Okay, so we have image here. What is image? We have learned image is nothing but the point of intersection of reflected rays. We have two types of object, point object and the extended one. Okay, and two types of images we have, the real one and the virtual one. What is real image? Real image is nothing but the actual meeting of reflected rays. जब rays reflect होकर के actual में किसी point पे meet कर रही हैं, that point is termed as the real image of it. But if they are not meeting there and just appear to meet, then it is called a virtual one. Let me show you by an example. Like if this is a parallel mirror we have, okay, and these are the rays coming, these are the incident rays. So after reflection they will go in this direction. Okay, like this, and they will go in this direction. So they actually meeting after reflection, as you can see. So this is the real image wave. This is the real image that we have. Okay, this is the real image. But what if this is the plane mirror? What if the rays are going in this way? So after reflection, they are moving in that way. Okay. So in the this side, in the reflected side, they will never meet. So what we have to do, we have to extend it to the further. Okay. So this here, this is the object and this is the image. What kind of image it is? It is the virtual image. Okay. Hello, Samsung. How are you? So spherical mirror and sign convention we have firstly. The first topic of today's class. So for spherical mirror, what is this? We have a sphere of glass. Okay. I am considering firstly the material is glass. So we have a bowl, we have a sphere of glass. Okay. And if we cut it, okay, we have two surfaces in that. Okay, as you can see here, a spherical mirror is a part of a sphere. Okay, there are two surfaces in a sphere. What kind of two surfaces are this? That you can see this image. This is the sphere. Look, this all is the sphere. Okay, that we have. There are two kind of surfaces over here. One is this, the outside surface, the outside surface, and one is the here, one is the inside surface. I'm writing it is here, inside one. So this outside surface is termed as the convex surface. Okay, we would see this as a convex one, and the inner surface is termed as the concave surface. Based on these two surfaces, we have two kinds of spherical mirror. Okay, so firstly, what we are going to do, to make any glass a mirror, we have to polish one surface. Okay, हमें एक सरफेस को क्या करना होगा, पॉलिश करना होगा या सिल्वर कर, उसे हम, that process is termed as the silvering of this. Okay, so if we polished that surface, okay, so that will not reflect any light, that will not going to pass any light from it. Okay, only the reflected side goes. So if we, let me move on to the next slide. I am telling it you here. If I just, if we polish the outside surface, which means the outside surface mean कौन सी surface? Con, convex, convex surface. Then the mirror, then mirror is called what? Is called what? अगर आपने आउटर सरफेस यानी कि आउटसाइड वाली सरफेस को पॉलिश कर दिया, देन द inner surface will be the reflected one. So that kind of mirror is termed as, in which inside, yeah, concave side is reflected, is termed as the concave mirror. Okay, so it is called as concave mirror. And the opposite of that, if we polish the inside surface, if we polish the inside surface, then the outer surface will be the reflected one. Okay, so that will termed as the convex mirror. Okay, let me show you by an example. All of you have in your house, okay, in your school also, there is an object in your mess called a spoon. Okay, everybody is seeing this. This is a kind of, this is a kind of both the mirror, it is playing the role. Look, this inside surface is termed as the concave, and this outside surface is termed as the convex. Okay, घर जाकर के या मैथ्स में जाकर के देखना, इन द आउटसाइड सरफेस पे आपको अब जो द इमेज ऑफ योर विल बी इरेक्ट वन, सीधी इमेज होगी, एंड द इनसाइड सरफेस विल हैव द इन्वर्टेड इमेज, उल्टी इमेज आएगी. ओके, so that could be the real example of it. Now concave mirror, the definition part that we have. and the convex mirror also. Yeah, from here I want to tell you something. Yeah, just a second. So if I just, for concave mirror, this is the surface that we have, and we have polished the outer surface. So this part is now the reflected one. So this is the concave mirror, concave mirror that we have. In the another one, yeah, if I just paint the inside surface, if I just paint the inside surface, then the outer surface will be the reflected one. This is the reflected surface, reflected surface, and this is the polished surface. Okay, polished surface. Here, this is the reflected one, and this is the polished one. Okay, so this mirror is termed as convex mirror. Convex mirror. याद रखने के लिए क्या करेंगे? In the mirror has the convex side reflected is the convex mirror, and the mirror have concave side reflected one is called as the concave mirror. Okay, got it? Okay, then if you have any doubt in this, you can write it in the chat box. Otherwise, we will move forward. Yeah. So there are important terms in spherical mirror that we are going to learn. Okay. There are few terminology that you would have to understand before going all through the just a second, before going to the mirror formula and all of that stuff. Okay. So this is the C. Okay. Firstly, the center of curvature. Center of curvature is nothing but, we know that the spherical mirror are the part of a sphere, and that sphere must have a center. So that center is termed as the center of curvature. Okay. So here this C is the center of curvature. Okay. The radius of curvature. Obviously, this sphere has to be a radius. Okay. So this radius is termed as the radius of curvature, the radius of the sphere. Okay. So it is the radius of sphere which the mirror is apart. Okay. जिस सरफेस का मिरर पार्ट है उसकी जो रेडियस है, that is the radius of curvature. Okay. What is the pole of mirror? Pole of mirror is nothing but the geometrical center of them. Look, if I take the concave mirror over here, this is the concave mirror. So this point, the geometrical center of it, is mirror ka, what is the geometrical center? This is termed as the pole. Okay, here we can consider this as a concave one. So this is the pole. This point is behave as a pole. What is the principal axis? This line is termed as the principal axis. Principal axis. How? So what is the definition of principal axis? Principal axis is nothing but which is passing through the pole and the center of curvature. That line is termed as the principal axis. Okay. What is normal? What is normal? Any line joining the mirror, okay, to its center of curvature, like this line also. This line will behave as a normal. Okay. Now, what is the aperture? Aperture is nothing but the reflected part. Like if this, my hand is the, you can consider it as a concave, convex mirror. So this part, this whole part, which is the reflected one, is termed as the aperture, which is responsible for the reflected. ठीक है, जो रिफ्लेक्शन के लिए पॉसिबल है सरफेस, that surface is termed as the aperture of that. Okay, the segment. Like in this spoon, this part is the responsible for the reflection. So this is called as the aperture. Now, it is very important. that I'm going to discuss right now, sign convention of mirror. So साइन कन्वेंशन के लिए दो तीन चीजें ही याद रखने की बात जरूरी है. Only 2 to 3 things that you have to remember. Okay, firstly, just a second. Yeah, firstly, let me just change the color of the pen so it will be more clear to you. Okay, so distance measure any distance any distance measured in the direction of in the direction of incident light would consider positive. Okay, and in the direction of the reflected rays it is considered negative. If you are moving up to the principal axis it will be positive. If you are moving down to the principal axis it is negative. So you can remember this by this quadrant. Okay, so if you are moving up, this is positive. If you are moving in this direction, what is this? This is positive also. This direction is negative and this direction is also negative. This is all. So if I place an object over here, this A dash B dash is an object. Okay. So what is the distance? Distance always be measured from the pole. Distance always be measured from the pole. Okay, हमेशा पोल से मेजर करेंगे. So if you try to measure this distance, this object distance, okay, so what it is positive or negative? Tell me in the chat box if it is positive or negative. Just look at the direction that we have moved. We have moved in the direction of reflected rays. Okay, so this direction would be considered negative. So this distance of object from the pole is considered to be negative. Okay, clear? Then now if you have any doubt in this sign convention, you can just write it in the chat box. Okay, or just raise your hand. Now the mirror formula and focal length we are going to focus. I have not discussed the focus on the previous one where I have discussed the all the terms, because focus is something that you need to focus more. Okay, so we have this mirror formula first of all. Okay, this is valid for all the mirrors that we have, like the spherical one, the concave and convex, both will satisfy this formula. So this is nothing but 1 upon f is equals to 1 upon u plus 1 upon v, where what is u? U is the distance of object from the pole of the mirror. What is v? V is the distance of image from the pole of the mirror. And what is f? F is the focal length of the mirror. Okay. So here in this you can see also, in this image you can see this is the object. This u is showing you the direction, sorry, distance of object, this u. This v, where is v? This is v. V is showing you the image. Here is the image formed. I will tell you that how this image will possible and how this formed. Okay, although this is not so much important to you, but just to be acknowledge it. Okay, so and this is the focus and this is the focal length. Okay, I am discussing it with now. अब हम फोकस के बारे में डिस्कस करेंगे. ओके, व्हाट इज प्रिंसिपल फोकस? Okay, so we have a mirror over here. What kind of mirror it is? It is the concave one. Got it? So concave mirror में क्या हुआ? This is ray which is moving parallel to the principal axis. After reflection, it strikes on the principal axis. Where? At the focus. So any mirror, if incident ray fall parallel to the principal axis on a mirror, spherical one, so after reflection from where it meets, from where it meets the principal axis, that point is termed as the focus of the mirror. Okay, that is what mirror is trying to say, that I am focusing these rays is this point. Okay, so that is the focus of the mirror. Okay, if mirror is trying to focus it just near it, it means the mirror has so much power, so much optical power, because it is not letting the rays to go down, go farther. Okay, so that is why focus is directly defining the power of the mirror. Okay, now if I read this definition, it is a point of intersection all the reflected rays after which the incident ray strikes on the mirror. Okay, with small aperture. छोटे मिरर के लिए ही ये पॉसिबल है, ये just keep this in mind. Okay, then yeah, for concave mirror the focus is negative. Why it is negative? Because for concave mirror, if you will see, this is the focus and this is the pole. If we measure the distance, this f, this is measured in the direction of, in the direction of reflected ray, so it will consider as negative. Okay, but for the, for convex one, here the image is inverted, but I will draw it for you like this, just a second. Yeah, this is the convex mirror that we have. This is the principal axis. Okay, and this ray is coming parallel to the principal axis. After reflection is goes in this direction. If we try to draw its path, it will be strike at this point. This is the F. This F will be measured from this P pole, and this distance is measured in the direction of incident ray. So it will consider as positive. So for concave, for convex mirror, it is convex. For convex mirror, focus is positive, and for concave mirror, focus is negative. Although I must tell you, the optical power of mirror is equals to minus of 1 by f. ठीक है, इसकी जितना ज्यादा फोकस होगा उसकी उतनी कम ऑप्टिकल पावर होगी. इट इज indirectly proportional to it. Okay, inversely proportional to it. Now, yeah, magnification, the part that plays a good role. Okay, so magnification, firstly we will define it. What is magnification? Magnification is nothing but, look, there is a mirror and the incident ray strikes on it. There is an object placed on the principal axis. Incident rays coming from this object, they are getting reflected, forming image. Now, how kind of image is this? Is this, क्या ये object से छोटा है? Is this small from the object, or it is bigger than the object? Okay, or one thing more, it is means सीधा बना है या उल्टा बना है. Okay, erected or inverted. Okay. So these all information is delivered by, is provided by this magnification. So magnification is nothing but the size of the image. It is the ratio of size of the image divided by size of the object. Okay, got it? So M is defined as the size of image to the size of object. Like if we have here like this, just a second. This is the object that we have. Let us suppose this is AB, and after the reflection, this here is the image formed. It is B dash A dash. Okay. So this is the height of image, and sorry, this is the height of object, and this is the height of image. So if I ask you what will be the formula for M over here, so it is the size of, means the height of image divided by the height of object. So height of image divided by height of object. Okay, this height of image is measured in negative side. This is the negative side, This is the positive side. This is the negative side, and this is the positive side. So this height of image is negative, height of object is positive. This is also equals to the distance of image formed, means from the pole it is V, and distance of object here is U. So it is also as the ratio of V by U, or we can say that M is equals to height of image by height of object is equals to the minus of V by U. You can consider it V with sign minus, and U will also come into here minus, because both V and U measured in the direction of reflected rays. So this minus would cancel out. This is the formula that you have. Now, this magnification, this magnification is termed as the transverse magnification. Transverse magnification. Okay. Why it is transverse? Transverse meaning perpendicular to the principal axis. So this object is placed perpendicular to the principal axis. This is the principal axis. Object is placed in this direction. So this magnification is termed as the transverse magnification. Okay. Now we will discuss one by one. So magnification of the linear object. Firstly, the case one that we would see is the if an object is placed perpendicular to the principal axis. Obviously we have seen it earlier, but I am drawing it for you. Okay, this is the concave mirror that we have. This is the concave mirror that we have. Just a second. Yeah. Okay. Yeah. This is the concave mirror that we have. This is the center. This is focus. This is pole. Okay. Got it? So like we have placed an object over here. This is the height of object, and an image is formed here. This is the height of image. Okay. So principal axis के perpendicular placed है. What is M? So M is the ratio of height of image to the height of object, which is also equals to minus of V by minus of by U. So this is the formula that we have, and this is the transverse magnification. Transverse magnification. Okay, I'm writing it in the shorter form. What if, okay, this is all. So if you have any doubt, you can ask. Now, if the object is placed parallel to the principal axis, okay, वो perpendicular था. If the object is placed parallel to the principal axis, so width object I'm not considering. Okay, this is the object A, B, and image is formed over here. This is B dash, A dash. Okay, this is the concave mirror we have. Okay, this is the principal axis. So here the magnification, what should be the magnification? Here it overalls, it depends on the size of the object, but here the height is not mentioned, only the length of object is mentioned and length of image is mentioned. So we would consider it as length of image or length of object. So M is nothing but here length of image to the length of object. Okay, which is also equals to, because length of image is measured in negative direction. Okay, and length of object is measured in the positive direction, so we can consider it as alignment. If you would say that this point, this A dash from pole is at V1, this B dash is at V2, because this is the image, so I am denoting the distance of this object, this image, from V1 and V2. Similarly, for this we have U1, and for this we have U2. So it is also defined as the difference of distances of images divided by the difference of distances of object, means V2 minus V1 divided by u2 minus u1. Same as the previous one. That would be the v upon u. It is the v2 minus v1 or v2 minus u1. So we can say here that m is equals to Li over Lo is equals to minus of v2 minus v1 divided by u2 minus u1. Got it? This magnification is termed as the this magnification is termed as longitudinal magnification. Longitudinal magnification. Okay, magnification. What is the difference between longitudinal and transverse? Longitudinal longitudinal magnification tells us about the length of the object. Okay, how lengthy is the images, and the transfer magnification tells us about the height of the image. Okay, so it is measured. Transverse means the perpendicular length is, and longitudinal means the horizontal length. Okay, clear? Now, if the object is so small, if the object is small, so what would happen? We have the mirror formula. Okay, we have the mirror formula. Let me just, this is 2D. Yeah, if we have the mirror formula here, which is 1 upon v minus plus 1 upon u is equals to 1 upon f that we have. Okay, so I just have to remove this one. Okay, no problem in that. You can write down from the below of it. Okay, this you cannot down. So 1 upon v, if we try to differentiate it, if we just differentiate it, what would I get? It is minus 1 by v square dv minus 1 upon u square du is equals to 0. What is dv by du is equals to minus of v square by u square. Okay, the differentiation of d by dx 1 upon x is equals to minus of 1 by x square. Okay, that is why this formula has been come. So this dv and du is nothing but the difference of difference of distances of image and object. So we would consider this as the longitudinal magnification. Okay, and this v by u is nothing but the transverse one. So we can say that this longitudinal magnification ml is equals to the square of the minus of square of the transverse magnification. Okay, got it? So these two formula that we have from the linear object. Okay, if you have any doubt in this, just feel free to ask. Okay, I will tell you that in these formula we generally have doubt, so please ask if you have any. Okay, so magnification of 2D object. 2D means अब तक हम one dimensional object के बारे में बात कर रहे थे. Now we will talk about the 2D object. So firstly we will have the case. Yeah, first case that we have, we place this object. Okay, which height is height of object, and this is the length of length of object, and the image is formed is this way. This is the height of image and the length of image. Okay, so what do we have? How do we calculate the magnification over here? Magnification is nothing but the size of image divided by size of object. Okay, so how we can calculate the size of image? By the area. So this magnification is termed as the aerial magnification of the object if the object is in 2D. So what would we have? We have hi Size of image means area of the this image. What will be the, this is the rectangle. So we have length multiplied by the height. So HI divided by HO. If you have any doubt in this, please feel free to ask. Okay, just a sec. Yeah. So what we are going to do, this MA is equals to HI over HO and LI over LO. We have seen this formula somewhere. हाँ, मेरे याद नहीं आ रहा अभी. अरे पिछली स्लाइड में देखा है. We have just seen this previous one. What is Li by Lo? Li by Lo is the longitudinal magnification. And what is Hi by Ho? It is the transverse magnification. So aerial magnification is nothing but the multiplication of longitudinal with transverse. And for small object, what we have? For small object, what we are going to do? We know that this ml is the minus of square of transverse. So if I just talk about the magnitude, this will be the plus one. So we would just put this value in this. So this ma here is the ml. If we put the value of ml over here, it will be the mt ka cube of the transverse magnification. Okay. So these are the important formula that you have. Okay. Now move on to the next case. Yeah. If the object is placed perpendicular to the plane of it, I hope you guys can imagine it. This object is placed like this. Okay. To the principal axis like this. So image here would be formed in this way. Here, the length, height of the object is hi, and here we will consider the width of the object. This is the height of the object. Similarly, this is the height of image, and this is the width of image. So what do we have in terms of magnification? Magnification here will also count as the aerial magnification, and it is nothing but the size of size of image, size of image divided by size of object. So we have, again we will multiply the area, so it will give us HOWO divided by HI. Sorry, just a second. What is happening? So HIWI divided by HOWO. This is the MA. Now you tell me how this HI and HO will count and this WI and WO will count. You will say that HI and HO is the transverse magnification. But what about the WI by WO? Is this lateral or transverse? Just tell me. Write it in the chat box. I will tell you one trick. If the object is placed perpendicular to the principal axis, that would be counted as the transverse one. Okay. Yeah. So this WO is the perpendicular to this principal axis. So it would be count as the transverse magnification. So here both are the MT, transverse magnification. Okay. So M aerial, very good. Shri Kruti Donpal, very good. That is why you have paying the attention to the lecture. It's good to hear. Okay. So this MA is nothing but the MT ka square over here in this case. Okay. So I hope you have got this. If you have any doubt, you can ask. Okay. Now, the velocity of image in spherical mirror. We have done this with I must say, with the plane mirror. So the last case that we have here is this. Just a second. Yeah. So we have here the object. Yeah, sure. I can show you the previous slide. Yeah. हो गया? Tonpal, have you got this? I hope you got this. I'm moving on to the next slide. Okay. 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 Thank you. So velocity of image in the spherical mirror that we are going to discuss now. So we have discussed it with the plane mirror. In the spherical one we are going to discuss. So this is the object that we have, AB. Okay. And somehow there is moving with a velocity of object. This we would consider in spherical one. This is the parallel component of velocity. Okay. And this is the perpendicular component of the velocity. Why it is so? Because here we are measuring this component with respect to this principal axis. Okay. So this is the concave mirror. Okay. This from here the image will be formed. So it is A dash B dash. The distance of image will be V. The distance of object will be U. Height of image is HO, and height of object is HO, and height of image is HI. Okay. So firstly, we will deal with this parallel velocity. Okay. One of every one of you will tell me that what is this change of this V parallel will cause. Does it change the height of the object or the image of the object? Does it change with the height and of the object and image? क्या इस वेलोसिटी का हाइट से किसी भी तरह से लेना देना है? No. This parallel velocity will change the distance of the object and image from the pole. Okay. So here we are going to use the relation 1 upon V on 1 upon U is equals to 1 upon F. Okay. So if we differentiate it with respect to time, then what will we get here is minus 1 by V square dV by dt. Okay. Because the firstly we will deal it as a function that it has 1 minus 1 by V square. Then the differentiation of this also with respect to time. Minus 1 by U square similar way du by dt is equals to 0 because focus is the constant quantity. So the differentiation of constant will be 0. So from here, what you can say that dv by dt is equals to minus of v square by u square du by dt. What is this dv by dt? V is nothing but the distance of image from the pole. So by changing this distance, we are changing the velocity. We are dealing with the velocity. Here, you would consider that this V is no the velocity. It is the distance. I'm writing it here. It is the distance. Okay. So this change of distance with respect to time gives you the image velocity parallel. And this is equals to V square by U square velocity of object parallel. Got it? So this is the relation that we have. Got it? Now the next relation that I am going to tell you about the perpendicular velocities. Okay. So for the calculation of velocity of image perpendicular. Okay. Velocity of image perpendicular. So again, This is the height of object. This is the height of image. The distance is v. This distance is termed as u. Okay. This is it. So what component of velocity we have? VO perpendicular, VO parallel. Okay. What component of velocity will going to change the height of the object? And if the height of object is going to change, then the height of image will also change. Okay. Okay. So the component which is responsible for that is this VO perpendicular. Okay. We know that M is equals to nothing but what it is. M is nothing but minus of HI over HO equals to minus of V by minus of U. Sorry for the ring. Okay. So M is equals to HI over HO is equals to V by U. Got it? Minus of V by U. Got it? Now, what I am going to do, I am just going to differentiate it with respect to time. So I would write it as M is equals to, sorry, HI is equals to minus of V by U HO. Okay. So if I just differentiate this, keeping the V and U as constant, then what would I get? Would get d of HI by dt is equals to minus of V by U dHO by dt. Okay. So this dHI by dt is nothing but the change of height of image with respect to time, which means the perpendicular velocity of image. The perpendicular velocity of image minus V by U. This dHO by dt is nothing but the change of perpendicular velocity or perpendicular distance. Yeah, means height of the object. Okay. So this we would write as VO perpendicular. So this is the relation that we have. This is the simplest relation, simplest way to derive it, I must say. Okay. So yeah, actually the time is, yeah, time has been gone. So I will discuss this image found by spherical mirror in the next lecture. Okay. Till now, if you have taken the screenshot of this picture, I want to discuss one question very okay. Yeah, I will discuss this here. So yesterday I have given one question to you. Just be here. Samsung Lab 2, I'm doing it for you and for everyone also. So I have just mentioned that this is the plane mirror. Okay. And this is moving with an angle 45, and we have 2 root 2 velocity it has, and there is an object which has 5 root 2 meter per second moving at an angle of 45. So we wish to calculate here the image velocity. Okay. So we would just firstly we will, what we are going to do, we will resolve it. Okay. So this is the perpendicular velocity with respect to the plane mirror. So object की perpendicular velocity is equals to the component in this direction. So if I tell you this is a vector and this angle is theta, so what would be the component in x direction? This will be a cos theta. In the perpendicular component we have a sine theta. So this is the horizontal component that we are going to solve. It is VO cos 45. Put the value of VO, it is 5 root 2. Cos 45 we have 1 by root 2. It will be 5 meter per second. So velocity of object parallel, again VO sine 45. So 5 root 2 multiplied by 1 by root 2, which is 5 meter per second. What about the mirror velocity? So velocity of mirror, again perpendicular one, which is the VO cos 45. Similar way we are going to do. Okay, this component is the perpendicular one. What is VO? VO is 5 root 2, cos 45 is 1 by root 2. So root 2 cancel out. Sorry, it is 2 root 2, na? So it is 2 meter per second. And what is the velocity of mirror in parallel direction to it? So it will be 2 root 2 multiplied by sine 45, which is again gives you the 2 meter per second. This direction we have considered positive. This direction we have considered negative. So what is the velocity of image? We all know that velocity of image parallel will not go to affect, okay, with the mirror velocity. Mirror कैसे भी move कर रहा हो, it doesn't affect the image velocity parallel to it. Okay, object भी अगर parallelly move कर रहा है तो image भी साथ में move करेगी, which means parallel velocities of image is equals to the parallel velocity of object, which is nothing but what is the parallel velocity of object? It is 5 meter per second. Got it? What is the perpendicular velocity of image? So we have the formula for that. Anyone going to tell me the formula? Okay, it is the velocity. Just a second. So yeah, so the formula we have, velocity of mirror perpendicular is equals to the velocity of image perpendicular, velocity of object perpendicular divided by 2. Simply it is the arithmetic mean of it. Okay. So I am solving it here, right in front of this. Here. Okay. So velocity of mirror perpendicular we have as 2 here. This is the parallel one, this is the perpendicular one. So 2 is equals to what is the velocity of, and this 2 is also in the direction, positive direction, in this direction. So we have considered it as positive. So velocity of image that we wish to calculate. What is the velocity of object? It is 5 and it is also in positive direction, divided by 2. So here we have velocity of image perpendicular, 2 2s are 4. Okay, velocity of image plus 5 is equals to 2 2 ja 4. This is the cross multiplication. Okay, if I wish just take this 5 on the other side, and velocity of image perpendicular will be -1 meter per second. And it is pretty much understood that if object is moving this direction, or image is going to move in this direction. In this direction we have considered negative, so that is why this perpendicular velocity of image coming out as a negative one. Okay, so guys, this is up from my side. If you have any doubt in every slide में तो नहीं होगा, in any one of the slide, then you can ask. Okay, or write it in the chat box, otherwise you can leave. Thank you guys, thank you so much for attending this lecture. Okay, thank you so much. थोड़ा responsive रहो, that would be better for you. Okay, if you would be the responsive. Okay, it is for the betterment of yours, so be responsive. Okay, Samsung Lab 2, did you got the answer? I think you are the one who have doubt in this question yesterday. Did you get it or not? Otherwise we will discuss it in the next lecture also. Okay, we are up to the mark. Have you got this? Okay. Okay. Thank you so much. Thank you so much to all of you. Yeah, your name is so heavy, that is why I'm not taking your name particularly, but you all are good, very good.